Hey everyone, welcome to the, sixth video of the square roots in Pythagorean theorem. Sixth, fifth, seventh, I don't know. But anyway, we are now talking about the sides of a triangle. We're continuing with what we did in the last video where we talked about the legs and hypotenuse, except now we're going to get some practice with the Pythagorean theorem and how to find missing sides, basically. So what's nice about this is we start to talk about applications. We start to look at things that are actually useful. And a lot of these, even though I'm just talking about triangles, try to picture that, there are a lot of practical things that involve triangles. Triangles are everywhere, whether you want to cross the field or whether you're plotting farmland or you're doing construction. Like, triangles are all over the place. So knowing Pythagorean theorem is extremely important. Okay? That being said, let's jump right in. We are going to start off by trying to figure out the length of a hypotenuse that we don't know. We know the length of A, that leg, and we know the length of this leg, which is 10. So we do know these, but we don't know the distance between these two edges. We don't know the hypotenuse. And to do that, we're going to have to use that information that we worked at before. So we talked about how the square, these are not really squares, but the squares of A and B add up to get the square of C. We're not going to draw squares anymore. We're not going to do little blocks. We're not going to do that kind of thing. We're just going to do the math part of it. But it is important to remember that that's where that comes from. We're talking about these squares, the relationship between those. But what's important here is to remember that the square of the two smaller sides, A and B, are equal to the square of the hypotenuse, the big side. And here we go. A is 7, so we're talking about 7 squared here. And B is 10, so 10 squared. C, we don't know. But now we can kind of solve. We do have some experience with squares and square roots. We did that earlier in this unit, so we should be able to find our way here. 7 squared. 7 squared is not 74, despite what my calculator wants to tell you here. 7 squared is actually 49. So we can write 49 instead of 7 squared. 10 squared, if you don't believe me that 10 squared is 100, there it is for you here. So 49 plus 100 is equal to C squared. Pretty sure you can add 100 plus 49. If not, well, I don't know what to say about that. But here we go. 149 is equal to C squared. This is the part where some people might get a little stuck. Well, what do I do here? How do I do this? How do I get rid of that square? Well, this is where the square root comes in. We're doing opposite operations. So if I do the square root of this side, I do the square root of the other side as well. But the fortunate thing is square and square root are opposite operations, so they cancel out, leaving me with just C here. And on this side, we have the square root of 149, which we can actually solve. So 149 squared is 12 point, yes, I know. It looks like it must be wrong, right? 12.206.5, maybe it is, I don't know. It's an ugly number. But remember, we're talking about the nearest tenth of a meter. So this could be the distance between things. And you're not expecting everything in the real world to work out perfectly. So yeah, it makes sense that it's not a perfect square. So to the nearest tenth of a meter. Remember, a tenth, when it's not a whole number here, it's tenth place. So we're rounding it there. 12.2 meters is the hypotenuse. So the hypotenuse is 12.2 meters. Okay. Some of them are going to be nicer than that. Like, I think this one might be nicer. No, it's not. To the nearest centimeter. Sorry. Tough luck. This is your time to shine. So what you're going to do here is the same thing I did. Remember that the squares of the two smaller sides add up to the square of the hypotenuse. So I want you to set it up the same way I just did. And remember to use a square root at the end to get rid of that square. And let's see if you get the same answer. Go ahead and pause the video. All right, you're back. So hopefully you've had a chance to try that out. And let me go here and erase that messy thing where I just did. And also show you my answer. So what I want to point out is nearest centimeter, which means not like tenth was a decimal place. This one's just plain old centimeter. So we've got the hypotenuse. I set up a triangle here, and I said that my g squared and my f squared added together get me my hypotenuse. So that means 10 squared plus 6 squared is equal to my hypotenuse squared. 100 plus 36 is equal to hypotenuse squared. So 136 is equal to hypotenuse squared. Now to get rid of the hypotenuse squared, I do the square root on both sides, leaving me with 11.6619 and a whole bunch of other stuff that I don't care about. But I remember to round it to the nearest centimeter right here, so that ends up rounding up to 12 centimeters as my hypotenuse. So that actually ends up being 12 centimeters. Okay, here's a quick and easy question for you to answer. It's in your little packet there. So you have the areas of three triangles, 81, 225 is the big one, and you don't know this one. You need to figure out what it is. And you know what? If you can do subtraction, I'm pretty sure you can solve this. So go ahead and pause the video and solve this real quick, and then unpause it to check your answer. All right. Hopefully you were able to figure out that 225 minus 81 is equal to 144. So 81 plus 144 is equal to 225, which means that this missing side here, the area is actually 144. Yeah. All right. Talking quickly about the sides, here's something that's memorable. Hypotenuse and the two legs. You have two legs, so does a right triangle. A leg and a hypotenuse. Okay. Oh, how did I shrink that? There we go. Okay, think about this. We have now the task set before us to find legs. We're no longer looking for the big hypotenuse. We have that, but we're missing one of the legs. In this case, we're missing the leg E, and we want to figure that out. But it's really the same kind of thing, except the end manipulation that we do with the numbers is a little bit different. But it's not that bad. All right, let's try it out. The length of leg E of the right triangle. Pythagorean's theorem is the same. The two sides that are smallest, we square those and add them up. So d squared plus e squared is equal to f squared. D squared is 9 squared plus e squared. I don't know. Is this even a 9? That looks like a Q now. This is a 9. And f is 41 squared. 9 squared is 81 plus e squared, I don't know, is equal to, I have no idea what 41 squared is. Let's use the calculator for that. 41 squared is, yeah, no wonder I didn't know it. It's 1,681. Now, unlike the other one where we added these two together, I don't know what e is. So what I'm going to have to do is subtract or add negative 81 to both sides. So if I add negative 81 to both sides, these are going to cancel out, and I have e squared is equal to 1681 minus 81. I don't even know why I looked at the calculator for that. I really didn't need to. That's just 1600. Now we're at the same kind of thing. We want to get rid of the square root, so we do that to both sides to give us e here. And the square root of 1600, the square root of it is, well, what do you think the square root of 1600 is? Just by looking at it. What's the square root of 16? What's the square root of 16? What is it? You should know what that is. What squared makes 16? So, if we add two zeros on there, what could it be? What could it be? Could it be? Oh, why did I say two zeros? I meant 1 0. It would be 40. All right, so 40 is the side E. It's 40 millimeters. Okay. All right. That was how we solve for a leg. I think now it's your turn. So read this one. It's the same kind of thing. Find that missing leg. Find that leg. Pause the video, give it a try, and then come back and see if you got it. Hopefully that was enough time and you paused the video and gave it a shot, because I am moving forward. And here's my answer. I don't know S, but I do know these. I set up my triangle and I have S squared plus 20 squared is 52 squared. So it's 427.04. I move this over, the negative version of it anyway, by getting negative on both sides. So 2704 minus 400 is equal to 2304. I do the square root of that, and it looks like an ugly number, but it turns out to be just 48 centimeters, which is an awesome number to end up with. All right, moving forward. Pythagorean triplet. Okay, so there are some really nice triangles out there. Some really, really nice triangles out there. And those ones will give you these fantastic numbers that you love to get, like we just had there. 52, 20, and 48. Those are all just beautiful numbers. Nice endings. We don't have to worry about decimals or anything messy. Those are beautiful. That is a Pythagorean triplet. It's any set of 3 whole numbers that represent the length of the sides of a right angle triangle. And it has to work with the Pythagorean relation. So what I'm really talking about are ones that just work out so nicely. So think about it right now. There's one really easy example that we looked at earlier. Hint, 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 way back, way back, way back. Where are you? Way back, way back. Not there. No, actually it was in a different video. But yeah, we looked back there and there was a nice one, a nice example of a triplet. So think of one that you might be able to come up with for A, B, and C that are basically perfect squares that match up really nicely here and don't give us decimals. So if you want to do that, go ahead and pause the video and try to think of one. You're going to encounter it very often. When you're done, unpause the video. Hopefully you were able to come up with one. The most common example that you'll come up with is the 3, 4, 5 triangle. You'll come up with those a lot. But, I mean, that could be doubled. It could be the 6, 8, 10 triangle. It could be tripled. It could be the 9, 12, 15 triangle. You know. Also, these are some other examples that work out pretty nicely. These are all examples of Pythagorean triplets where these 2 numbers squared are going to be exactly that one without any decimals or any messy business. Okay, we're at the last question here. This is it's not a show you know, but I want to treat it that way, so we're just going to look at this here. Kira calculated the missing side length of the right triangle. So we have a right triangle here. We know it's a right triangle because of this thing, the little box here. Hypotenuse is 13. We have a side leg that is 5 and one that we don't know. We're trying to find y. So Kira sets up the example of y squared is equal to 5 squared plus 13 squared. And then she solves all this and she gets that as an answer. Now, what she's saying is y is equal to 13.9 centimeters. Is she correct? If she's correct, explain how you know she's correct. And if she's incorrect, find out where her error is and explain why. All right, so hopefully you're looking at this and you're like, wait a minute, that 13.9 centimeters is bigger than the hypotenuse. That just doesn't make sense because then 13.9 would be the hypotenuse. Mystery, that does not work. And you're right, she made a fatal error. And what I'd like you to do is, if you can pause the video, try to find the fatal error that she made that led to the wrong answer. When you are ready to move on, unpause the video and I will tell you what she did wrong. All right. So what Kira did wrong is actually she set up her initial equation wrong. She put y squared as her hypotenuse. But remember that it's the two squares of the two smaller sides that add up to the hypotenuse. So it should have been 13 squared is the hypotenuse here, equals y squared plus 5 squared, or 5 squared plus y squared. So these two she accidentally swapped, or I don't know if that's considered an accident. But anyway, she is not correct. She didn't identify the hypotenuse and set up the equation correctly. And now my little guy there over in the corner is saying stop, it's time to stop. So we are stopping this video. And I believe there's one more short video and we are done with this entire unit.